Hey guys, so glad you're here. How this video works is you're going to need paper and pencil so you can write down the questions. Make sure you include the first one, which will come up right now. It'll be the title. After the title, there'll be a short video and then it's going to change over and give you a question. Okay? Have a good time.
The equation mat. The equation mat is a relationship between what is in this rectangle and this rectangle. The relationship is that of being equal. And we're only going to be talking about coins being equal. There will be other items in the boxes, but the only thing we have to worry about when it comes to equality is coins. So in the equation mat, it must always be true that the number of coins on one side of the box, wherever it is in this box, shall be the same as the number of coins in this box. So now let's check this out. We still have the equation mat, and the same thing still holds true. On this side of the equal sign, in this rectangle, the number of coins has to match the number of coins on the other side of the equal sign in this rectangle. Okay, so as you can see on the right side of the rectangle, there are 4 coins. On the left side, we have a piggy bank. Since we cannot see the coins, then we can assume that the coins are inside the piggy bank. This situation is just a little bit different, but the idea is still the same. I have to have the same number of coins in this rectangle on this side of the equal sign as there are on this side of the equal sign in this rectangle. So how can we figure that out? I'd like you to think about it. How many coins must there be in the piggy bank so that there are an equal number of coins on each side? If you know already, you can put in your answer and explain how you know. But if not, here, let me show you something we can do. So there's these 3 coins that are out here, just kind of lying about. And there's all kinds of coins over here. But I'm going to put these down here to match the ones on this side. And I'm going to put these up here. And what I'm going to do next is I'm actually going to remove 3 coins from this side. And 3 coins from this side. Huh. Now that I've removed that pesky extra coins from here, I can see that my piggy bank has how many coins? Put your answer in the text box. Hey, how do you like this situation? Now we have two piggy banks. Hmm. In this situation, we're going to assume that the piggy banks have the exact same number of coins. If this piggy bank has 2 coins, this piggy bank has 2 coins. If this piggy bank has 20 coins, then this piggy bank has 20 coins. Okay, but to figure this out, we need to go back to our most important rule. The number of coins on this side of the equation is equal to the number of coins on this side of the equation. And since there are no coins hanging out here, we know all the coins are inside the piggy bank. So let's do this. If this piggy has 1, then this piggy has 1. So I'm going to separate this a little bit. If this piggy has 2, then this piggy has 2. If this piggy has 3, then this piggy has 3. And we can keep going like that. Have you figured out how many coins are in each piggy? If you have, put your answer in. If you're not quite sure, just wait till the end of the video and see how you feel about it. So go ahead and write down what you think. How many coins are in each piggy? How many coins are in one piggy bank? Okay, so this one looks pretty simple, doesn't it? Well, at this point in the game, I think you can try something a little more challenging than this. So I'm going to change the question on you. See, before I started recording, I did something sneaky. I took away 2 coins. So now I need to figure out how many coins were in the piggy bank in the first place. And to represent the 2 coins that I took away, I'm going to change the color so that you know there are 2 coins that I took away. So I have a piggy bank. I took out these 2 coins, and what I had left was these 3 coins. How many coins were in the piggy bank in the first place? If you know the answer, put it in the box and explain how you know. And for the rest of us, let's look at this a little bit more. Okay? So what I'm going to do, since I took the coins away, well, I'm going to put them back in. So I took 2 coins out from here, so I put them back in. And then I got to put them back in over here too. And there you go. So, how many coins were in the piggy bank in the first place? Okay, so what's going on here? There are no coins on one side. So how many coins does the little piggy have? 0. Okay, done. Just kidding. Okay, no, what we're really going to do is I'm going to show you right now. We're going to divide our little piggy. Don't worry, it's a piggy bank and it's not real, so it's not going to hurt. But we're going to divide our little piggy into 3 sections. Okay, so there are our sections. And they are equivalent sections so that this is the same as this, as the same as this. They all have the same amount of coins. So what that means is if that section has 2 coins, then that section has 2 coins, and that section has 2 coins because they're all the same. Okay? Now let me turn this guy around and I'm going to show you I'm going to turn it around just to make it easier and show you what we're going to do. Okay, so we have our little piggy has been divided into 3 sections. And here's the problem. Okay, so let's just look at one section. Okay, let's look at this one section here. And so in this one section here, we're going to say, what if there were, in this one section here, 5 coins? So this section here, which has been divided by 3, right? Because it's 3, we divided it into 3 parts, that's dividing by 3. This section has 5 coins. Yeah? So that the question then becomes, how many coins are in the entire little bank, little piggy bank? Well, if we add back this section, that means there was in that section 5 coins. And then we put back this section, and that's another 5 coins. So we multiplied this section by 3, and we got 15. Okay, let's look at this problem here. Again, remember that the number of coins on this side has to be the same as the number of coins on this side because we have this equal sign in between. Okay, so I have 2 little piggies and they each have the exact same number of coins. And then I have these 3 coins out here just kind of hanging out. It's the pesky little coins. Okay, well, I know that this is even, so I know I would have to divide these up into 2, but I have these 3 extra ones here. So what I'm going to do is I'm going to get those 3 extra ones. Do you know what I'm going to do yet? Okay. Yeah. I'm going to get these 3 extra ones because I just want to know how much is in one piggy, right? And these guys are just extras. But it has to be balanced because what's on this side has to remain the same as what's on this side. And right now they are the same. whatever's in this piggy plus whatever's in this piggy plus these here is the same as all of these together. Okay? So to make sure I keep the balance, I'm going to get rid of these coins here. There's 3 of them. So I'm going to take those away. And I'm going to get rid of these 3 coins on this side so that I can show, yeah, now that it's in balance. Okay, because if I took 3 out and I took 3 out, that means that what's left here is what belongs in these little piggies. So then, since there's 2 of them, I'm going to divide these coins into 2 parts. One here, one here. Has anybody figured it out yet? Go ahead if you already got it. And one here, and one here, and one here, and one here. So, to clean this up a little bit, how many coins are in one piggy bank? Okay, so what do we have now? Okay, it's a corral, and I just want you to show that these are together. And I wanted to show you that I have here the exact same thing twice. So I have 2 groups of a piggy bank and 3 coins. So how do I solve this problem? Well, there are a couple of ways, and I'll show you both. And you'll need to see both because you'll want to be able to compare and contrast as one of your answers. Okay, so let's look at this one here first. And what we're going to do this, since these are exactly the same and I have 2 of these groups, what I'm going to do is divide this into 2 sections. And so that means I'm also going to divide this into 2 sections. Let's see if we can get, there we go. Okay, so 1, 2, 3, 4, 5, 6, 7, and 7. Okay, so remember the goal is to find what's in one of these little piggy banks. And these are exactly the same. So I'm just going to work with this half here since this is exactly the same as that. And I'm just going to get rid of these. Once I've divided it into the 2 sections, I don't need that one. And now I can just work with this part here. Now, here, these are still stuck together. So the next thing I'm going to do is ungroup these. Okay, now I have ungrouped these.
It's 7 o'clock.
And I can work with these separately, the coins and the piggy bank. And I can do as we have done before, is I have these 3 extra coins hanging out here. And so I'm going to take 3 and I'm going to get rid of these. Remember, we have to have the same amount of coins on both sides. So if I get rid of 3 coins on one side, I have to get rid of 3 coins on the other side, or else it will be unbalanced. Okay, so now can you tell how many coins are in the piggy bank? I hope so. Now, let's try the second method. So let me undo all this stuff. Let's go back to that corral. Where is that corral? Oh, there it is. Okay, but yeah, no, we still don't need it. So let's get rid of it. All right, here we go. Okay, this time, instead of dividing it by 2 and then ungrouping, I'm going to ungroup them first. So I'm going to take all of this and ungroup everything. Okay, so now I can separate my piggies. So I have my piggies over here, and I have my coins over here. And let's see how many coins there are here. Okay, well that makes sense, right? Because each group had 3, and I had 2 groups, and 2 times 3 is 6. Okay, so then over here, I'm going to bring down 6 coins. And I'm going to now get rid of these coins. So all I have to work is with the piggies. Remember, we just want to know what's in one little piggy. So I don't need all these extras. And I get rid of 6 here. And to keep it balanced, I get rid of 6 there. And they're gone. Now here, I'm going to separate this. I'm going to divide this into 2 parts. And that means I divide this into 2 parts. Yeah, there's 4 here, 4 there. So I divided that. So now I only need to know what's in one piggy bank. So I can get rid of this. And does that look familiar? So, which method did you like best?
For this problem, use method 1 to solve it. This is the first challenge problem. Try to include method 1 when solving it. This is a matching activity, but because it's on Desmos, we're going to have to find a different way. So what you can do is label each card as A, B, C, D, E, F, G, H, I, J. And then next to that, just write the equation you believe goes with the card. So I'm going to go through each card and make it bigger so that you can see it. And I'll see if the equation, see if I can do that with the equations also. Okay, so I'll go through the cards first and then the equations. And in regards to the equations, remember that parentheses represents groups and that the variable represents an unknown value, which is usually what we're trying to find the value of. Okay, so here we go. We'll go in a little bit bigger so you can see the writing on there. Okay, so those were all the cards. Let's look at the equations. Maybe we could just zoom in. I guess that's as far as we can zoom in. And I will click on each one. Okay, let's do that one more time. So these are the equations. And good luck with this. Have fun. Okay, these problems, you are to work on another sheet of paper. Give it your best shot. If you're not sure, please come see me in my office hours, which is noon every day except Wednesday. It's at 12:15.